All right, so the next part is going to be some proof practice. And so we are going to start this one by looking at what we're trying to prove. So we're looking to try to prove two triangles congruent. So I'm looking for one of those four congruency patterns. So let's start with our given information. Our first piece of given information is that we have segment MO, and that is congruent to segment TO. So let me mark that off here, that we have segment MO congruent to segment TO, and that is given. And then we think, well, what information can we then draw from that? And that's really just something that is just a one-off. We can't take and expand upon that. So I'm going to go to my next piece of given information, which tells me that segment MT bisects segment NP. And that is also given. But what's different is that's going to trigger some information here. So if we have that MT bisects NP, then we know that the next thing that we need to be able to do is be able to name the midpoint. And so that O is going to be the midpoint of segment NP. And that is going to be just our definition of a segment bisector. Now, if we have the midpoint, what we should know next is that we're able to then say that we have two congruent segments, and so that's going to be segment NO congruent to segment PO, and that is by our last statement, which was a midpoint, so definition of midpoint. And so I'm going to mark that off, that we have a segment NO congruent to segment PO. And then I think, well, is there anything else from this given information that I can draw any statements and reasons from? And at this point, I think that I've exhausted all of that. So then I'm going to look and see, well, what do I have here and what do I still need? So what I see is that I have a side, and then I have another side. And so I'm looking for either a third side or an angle. And what I notice is that if I look right here, that those angles are vertical angles. And so I can say that angle, which would be MON, and the angle would be here, TOP. I first have to say that they are vertical angles, and and that would just be by definition. I then have to take it one step further, and I've got it to be able to say that they are congruent. So I'm going to say that angle MON is congruent to angle TOP, and that's our vertical angle theorem that tells me that vertical angles imply congruency. And so now I look at what I have, and I have a side, an angle, and a side. And so I'm going to be able to prove that these two triangles are congruent by side, angle, side. So I have enough to be able to say that angle MNO is congruent to triangle TPO. right, if I look at the next one, we are trying to prove with this. I first take a look at that, and I can see that I'm trying to show that I have an angle congruent to another angle, which tells me that I need to at first look down, and I can see that I'm going to need to get these two triangles to be congruent, because I know that what's going to happen is that once I get those two triangles congruent, I'm going to be able, by corresponding parts of congruent triangles or congruent, be able to say that I have angle A congruent to angle D. So I kind of know that up front, but I want to make sure that I can get to that point. So I'm kind of looking ahead. Now this one has some statements filled in for us, and as I've been working with some of you, keep in mind that we do have some wiggle room with the order of what certain things are said. So we're trying to give you some of these statements in here already filled out to help guide your thinking. But there's definitely, different ways to start and do some of the problems. So if we look at this first one here, it says that we have segment DC perpendicular to segment AD, and that is given. And now we think, well, what can we pull from that given information? Or if we look at that, one thing that we can say is that we know that we're going to have, if we're talking perpendicular, that we're going to have right angles. And so I'm going to say that we have angle ACD and angle DCB. And if those are perpendicular, then we know that they are right angles. And the reason is just that that is the definition of perpendicular. Okay. Where then, if there are two right angles, then what we know is that angle ACD must be congruent to angle DCB. And we know that because we know that all right angles are congruent. So I can go ahead and mark this off here. All right, and so then the next piece of information is that segment BC bisects angle ABD, and that is given. And then from that, I think, well, what does that tell me? And it tells me that I have angles that are congruent to each other. And so that would be angle ABC. And that is congruent to angle DBX. Oh, sorry, DBC. And that is because we know that's a bisector, so it's a definition of an angle bisector. And so I'm going to go ahead and mark that piece of information off. At that point, that's all that I can draw from the given information. And so I'm going to take a look and say, well, I have an angle, and then I have an angle. And what I notice is that I have this side to itself. And so my next thing that I could do is say that segment BC is congruent to segment BC, and that is reflexive. And there's my side. And so I'm now going to be able to say that these triangles are congruent by angle, side, angle. So I'm going to have triangle ABC congruent to triangle DBC. And we already said that's by angle, side, angle. And so now I have enough to be able to say that angle A is congruent to angle D. And that's because the corresponding parts of congruent triangles are congruent.